Use the following velocity readings to estimate the total distance traveled, first using right endpoints and then using left endpoints. Perfect. All right, we've got times from 0 to 30, so we're looking at a 30-second interval. So we're going from 0 to 30, and it looks like every 5 seconds we've got a reading. So 5, 10, 15, 20, 25, 30. If we're using right endpoints, that means that we're looking at all of this data except we're throwing out 0. Because the first right endpoint is 5, the next one is 10, all the way up to 30. So basically, we're looking at all the data except we're ignoring the 0. So we know that distance equals velocity times time, or time times velocity, either way. And each of these intervals has 5 seconds as the time. So for the first interval, we've got 5 seconds times that first velocity is the reading at 5, so that's going to be 15. So 5 times 15 plus the next interval is 5 seconds times a velocity of 20, right? The next interval we're using 20, and so on and so forth. It's going to be plus 5 times 26. Oops, that should be times. Plus 5 times 32, plus 5 times 38, plus 5 times 45. And when you add all of that together, you get 880 feet. So that is our approximation using right endpoints. We can also use left endpoints. I guess I should call this D sub R and D sub L for right endpoints and left endpoints. Now for left endpoints, we're using all of this data except 30, because 30 is not a left endpoint of any intervals inside this interval that we're looking at. So it's going to be the same thing, but instead of using the numbers from 15 to 45 in our calculations, we're going to use the numbers from 12 to 38. And in fact, I'm going to do one quick thing. Remember how each of these was multiplied by 5? I'm just going to factor that out and put the 5 out front. And then inside the data that we're using are all the left endpoints. So 12 plus 15 plus 20 plus 26 plus 32 plus 38. And that's it, not 45, because that's a right endpoint, not a left endpoint. And when we add all of these together, we end up with 715. So our left-handed estimate is 715 feet. The right-handed estimate is 880 feet. We don't know if it's closer to one or the other because we really don't know how the function is increasing and decreasing in between these points. When we had the area problem, each of those examples, we had a nice graph, and we could kind of eyeball it and see if it looked like we were overestimating by a lot or underestimating by a lot or vice versa. But here we don't have enough data to really get any sense, and the best we can do is just say that these are our estimates, and it's probably somewhere in between them, though not necessarily.